Okay, so let's go ahead and start. So today's session is primarily on basics about Scala. We have seen how to set up the environment as part of the last session. I hope everyone have set up the environment. If not, please do so by next class, which is tomorrow, so that you actually develop applications using Scala IDE. Today's class will be theoretical. There won't be any exercise as of today. Probably tomorrow, latter part of the class, or day after tomorrow, we will start the exercise. And the main goal about the exercise means whatever the main exercise which we'll be doing on Scala will be this one. I will share in a Word doc also as requested by Tawant folks. But as of now, I am recording everything as part of my forum. But by tomorrow or day after tomorrow, you will have all the exercises which you will be doing for the Scala workshop especially. Okay, so under workshop exercises, you will see all the exercises which we'll be doing. So whoever is not on mute, please go on to mute. Hello. Okay, let me do this. Okay. Okay, so this will be the main exercise which you will be doing either from second half of tomorrow and or you will be doing day after tomorrow. This one will take at least couple of hours to complete in appropriate manner, following all the best practices. So once I cover all the basics of Scala, what you will be doing is you will be creating couple of dependencies, external dependencies, which are not part of core Spark. One is the JDBC driver for MySQL, and other one is type-safe config for externalizing parameters such as JDBC URL. And this requires usage of MySQL database. For now, you can use my database, which is on the lab. We have MySQL also as part of the lab, and you can use that to connect. And it has a database called HR. You will be using it to finish this exercise. If you don't have lab access for any reason, or if you want to just develop on your PC, you can do so. But for that, you have to set up MySQL database on your PC or some other server where you have access to. And I provide a DML script, DDL and DML script, which will create all the tables and insert the data into those tables. And then you should have employees table, a table called employees table. It has around 10 columns, and one of the column is salary and the other one is commission percentage. So the outcome of this exercise will be to read the data from that employees table, especially employee name, salary, and percentage, commission percentage, and you should compute commission for each and every employee. There are employees who don't have commission percentage. For that, you just have to say not eligible or N by E. So this will be the output. This is primarily to understand end-to-end flow about how we typically develop Scala applications. It is applicable to any programming language. Typically, we use some database to store the data, to read the data from, and then we will apply our business logic. So here the business logic is very simple. It's not very complicated. The emphasis will be on understanding the basic programming constructs of Scala. Okay, now let us get into the details about some of the Scala programming basics. So first question you should answer whenever you think about a programming language. Either a programming language is interpreter-based language or compiler-based language. So which type of language is Scala? The answer is Scala is a compiler-based language. And when actually Scala program compiles, it compiles into Java bytecode. So the same way Java compiles into Java bytecode, Scala code also compiles into Java bytecode, and it runs in JVM. But the syntax is significantly different from Java. Okay, that you need to understand. Scala is a compiler-based programming language, yet it is significantly different from Java from the syntax perspective. Okay, so now we will talk about syntax. The first thing, if you think of any programming language, the first thing you try to understand will be the data types. Okay, so when it comes to data types, yeah, before getting into that, Scala has few components as part of it. One is Scala command line interface. It is also called as Scala interpreter in some cases, and in some cases it is called as REPL, REPL. REPL stands for read, execute, print, and loop. Okay, so Scala is kind of REPL command line interface or interpreter, whatever you call. You can use this to write program snippets in interactive fashion. But whenever you type a code snippet in Scala, internally it will apply all the required logic to generate the bytecode the same way Java generates the bytecode. For example, in Java, if you have to write a hello world program, you have to write a class specification, and that you have to write a main function, and in that you say system.out.println and hello world. So it takes around 7 to 9 lines of code to just print hello world in Java. In Scala, the same thing can be accomplished by saying print hello world. Sorry, print hello world, and it will print hello world. So what will happen when you type that and hit enter? This print hello world will be compiled into Java bytecode, and to compile into Java bytecode and to run, it has to embed into a class, a main function, etc. All those things will be taken care internally. You don't need to worry about it. Scala is smart enough to do so internally. So you can develop whatever you want using this Scala interpreter or Scala command line interface or REPL. You can declare variables, you can create functions, you can create classes, you can create objects, you can do whatever you want. Okay, so first let us start with data types. So you will be familiar with data types, all primitive data types such as integer, float, double, and then some complex data types such as string to store the string, etc. Like Java, Scala also have a class hierarchy. You can actually go to Scala official documentation. It says docs.scalalang.org. Here you can see there are different types of they have categorized the documentation into different different categories. One is guides and overviews, so which will actually cover guide of a typical of a particular component. For example, collections. If you want to understand about collections in detail, this is the way to go. You can click on this and you can see it has documentation about Scala collections library and a few more Scala doc, the multi-thread programming. All those things are covered as part of this guides and guides and overviews. And then tutorials is the one which will cover the basics of Scala programming. Okay, it's like Java programmer guide. So these are the core basic constructs when you want to start develop programs using Scala. 1 minute, okay. Okay, so you will be going to tutorials, but unfortunately this tutorials is not up to date. For example, if I want to talk about the class hierarchy of all the classes in Scala, this is a little bit outdated. Some of the classes are deprecated or changed to something else. You can go to the comments and you can see this is not updated for a long time, and this comment is made almost eight months back. So they are not very good at managing this document. but still it will give good overview about whatever they have made available for us to develop applications using Scala. So if you zoom in a little bit, these are the primitive types: double, float, long, int, short, byte. Like Java, we have primitive types similar to Java. But one thing is, unlike in Java, either you can declare a integer saying int, or you can also create an integer object, right? In Scala, there is not that distinction. If you want to define it as a integer, either you have to say val I equal to 0. I will explain what is val in a moment. Based upon the value assigned, it will automatically inherit the data type. Here, we assign 0, 0 is of type integer, and it automatically inherited. Even if we have to define data type, we just have to say like this. So syntax is different. You need to make sure you understand the syntax. It's significantly different from Java. 1 minute, okay? So both are same. The previous statement and this statement are same. So if you have to define data type, you have to define like this. Okay? Yes, Banu. Okay. Yeah, I don't know. You have to elaborate what you have missed. So here you can see that you can define variable like this. Unlike in Java, where we say string and then data type name, here we have to start with a keyword called val or var while creating the variable. I will explain what is val and var in a moment. But this is how you define variable and the data type if you have to define the data type. In most of the cases, you don't need to. It will be automatically taken care by the Scala compiler itself. And also, when you actually define the data type, you don't need to use the int in some cases and then class integer in some cases. You can safely use int and it will take care internally. Hey, Bani, you have to elaborate. I could not get what you were trying to convey. Okay. So this is how you can declare the variables. So if you want to create string type variable, you can say t, and you can then say hello world. And now because we are passing string, it automatically created a string type of variable. So you just have to go through this page and see what all primitive data types that are available, and you can start exploring those things. And then there are some special data types such as nothing, null, any, etc., which we will cover later. They are not very important at this time. We will cover those things later. And while defining data types, you need to understand the difference between val and var. So typically, if you want to create a variable in Java, if you are from Java background, if you want to create a immutable variable, especially for multi-threading, you have to declare a variable as final. Okay. The best practice says make your objects immutable unless and until it has to be mutable. But unfortunately, by default, Java variables are mutable. And if you want to make it immutable, you have to say final wherever you declare the variable, right? Here in this case, there is no that default behavior. You have to tell whether the variable is immutable or mutable. So if you say val, it is immutable. If you say var, it is mutable. And Scala syntax requires this val or var when you create the variables. Val for immutable and var for mutable. For example, in this case, I have created I, a immutable variable. Now, if I want to reassign to different value, it will fail, saying that we are trying to reassign to val. If it is var, I'm creating a new variable called j, which is of type mutable integer because we are assigning 1. And initialization is mandatory. You have to assign to some value. And now if I want to reassign, I can do that. Okay. If I say val I again, and that's what is happening is I am recreating the immutable variable. It has destroyed the earlier immutable variable I, and it has recreated new one. We can do this, but we cannot reassign without saying val or var to the same variable which is declared earlier. It will complain saying we are trying to modify the immutable variable. So it's very, very important. Val and var is very, very important, and unless and until it is absolutely required to be mutable, we have to make it val. Otherwise, we have, wherever it has to be mutable, we have to make it var. So this is about the data types. You don't need to define the data type. So this is about the variables. Giving the data types to the variables is not mandatory, but specifying whether they are immutable or mutable is mandatory. And then the next thing which you need to understand is the programming constructs for any programming language, not only for Scala, whether it is Java, Python, JavaScript, whatever it is. First thing you need to understand is how we actually declare the variables. Second, how to implement conditional logic, loop logic, etc. So as any programming language, we have if condition, we have ternary operator, we have while loop, we have for loop. All are available in Scala. Okay. So here, let me go to okay. Just give me a moment. So Banu, what is your question? You didn't type the question. You just say I missed. I don't know what you have missed. If you can elaborate, I can explain. So here you can see different variables, different examples for each and every type of condition. This is how if else condition look like. Like any programming language, you just have specify the condition in if, and then open curly braces, and then take the necessary action as part of the if condition. If you want multiple if else, then you can put these things. Okay. And then okay, you have to take it offline. I will share my contact number with you after the class. Just let me know what is the issue, and I will take care. Okay. I cannot go back now with whatever you have missed. We have to take it offline. So this is how if condition looks like. And in Java, if you want to create a ternary operator, how will you create? You will say if I greater than j, if this condition is true, then do something, otherwise do something else. This is how ternary operator look like in Java. Whereas in Scala, they made it little bit more readable in line with the if else condition. This is how it will look like, the ternary operator. If this is the condition, you can say this, else you can say this. Okay. This is how you can actually define the ternary operator, which is a little bit better in readability compared to ternary operator in other programming languages. And while loop, as any other programming language, you can actually loop through. The syntax is almost same. When it comes to for loop, you will never find syntax like this. For I equal to 0, I less than x, and then I plus plus, and then you give some whatever logic you want to implement in the loop, you will put it in curly braces, and you will try to implement. Whereas in Scala, it is how it will look like. Okay, you can give the range like this, and you can loop as many times as you want in that range, and you can take the necessary action, and you have to give this syntax to assign each individual value of this loop into this variable. Whether you are using collection, whether you are using range of values, whatever it is, the syntax is same. You don't need to change depending upon the type of activity you are doing. In Java, you use different syntax while reading from collection, you use different syntax while reading from range. Here, it's a unified syntax, whether you read it from collection or you read it from range. So these are the basic programming constructs for implementing the conditional logic, loop logic, etc., like while loop, for loop, etc. And then we have covered variables and data types. Then we have covered different conditions, how the syntax look like. The next thing is functions. Okay, and the Scala is called as functional programming language, because whatever mathematical functions, whatever are the characteristics of mathematical functions, these Scala Scala language developers try to implement those things as part of the programming language itself. There are other programming languages also. Scala is not the first one. There are many other functional programming languages, and Scala is one among them. So it will give a lot more flexibility while dealing with functions in Scala compared to programming languages like Java. Okay, I'm not very strong in mathematics, so I don't know the appropriate terms. So I will not get into too many details about the characteristics of functional programming, because that is not that important. More the important is about how to implement business logic for data processing or application development, whatever it is. So I will emphasize more on that rather than theory about whatever the characteristics of functional programming language implemented in Scala. Okay, so writing functions, it look like this. So if you want to create a function, for example, let's say I want to create a function add integers. It take two variables. Okay, so the function specification starts with def. Whenever you try to create a function, unless it is anonymous function or closure, there are different types of functions in Scala. One is regular function. So here I am showing an example for regular function. So it starts with def, then you have to give the function name, and then you have to pass the parameters. And here you don't need to specify val or var, because Scala clearly distinct between variables and parameters. Here these are called as parameters. Parameters requires data types only. It does not, you need not tell whether it is mutable or immutable, because you have to assign values to those parameters while invoking. It doesn't make sense to make these mutable or immutable while defining parameters here. You just have to say the variable name and the data type, and then you also have to say the return type. In this case, when we add two integers, the return type will be integer, and then say equal. So this is the function specification. You have to start with keyword def, function name, give the parameters with data types. Once that is done, you have to give semicolon and give the return type, then equal, then in curly braces you have to implement whatever logic you want. So let's say here val total equal to I plus j. Okay, and here in Scala, unlike in Java, you don't need to end line with semicolon. If you want, you can, but it is not mandatory. So whether you add semicolon for each line or not, it will not make any difference in Scala. Okay, so you can hit enter here, and then we want to return this total. So how can we return it? Typically we can say return total, and it will return the total. However, in Scala, they have made lot of stuff optional. Already we have seen example where data types need not be defined for variables. Here you can see we are not defining data type for this variable. So defining data types is optional. Similarly, when it comes to returning the statement, you don't need to specify return mandatorily. You just say what you want to return at the end of the wherever your return points are, and it will return that value. So it's about typing less to develop the programs. Okay, so here I can say total and hit enter, and now the function is created. So this means return total. Okay, but if you want, you can specify return. If you don't want, you don't need to. Whether you specify it or not, as long as this matches with the data type of the return value, it will return that without any issues. Okay, now I can actually invoke saying add integers 1, 2 and hit enter, and it has returned the total of the sum of two values. Okay, so this is how you can actually declare the functions, and you can invoke the function. And when it comes to Scala, you can pass a function as a parameter to another function. For example, now def multiply values. So this is because we are not assigning to any variable, it is creating implicit variable res2, and it is displaying, it is giving data type of that, and it is showing the value here. So if you don't want to display that, what you have to do, you just have to say print add integers 1, 2. Okay, otherwise it has to assign some variable, and this is implicit variable which is creating internally to store this value when we are invoking this function without any other thing around it. It could be print function, it could be any other function. Okay, now we can actually say def let's say multiply values. Okay, here I can say I int, and I want to pass a function itself as a parameter. Okay, I can say j add integers. I'm not sure whether it will work or not. Let me see. Okay, let us see. Total equal to I into j return total. No, it will not work. There is a way. There is a way to pass the function. I do not remember, but we can pass the function. Let me try this one. There is something called anonymous functions. We can actually pass the anonymous function. I will cover that a little bit later. Yeah, correct. No, I will cover a little bit later. Now I could not recollect on top of my head, but we can pass functions also. Let us cover high-level functions, then we will get into invoking other functions, etc. Okay. So this is a regular function which we have seen. If you want to create anonymous function, okay, so let's say yeah, let's say I want to just give me a moment. So okay, object higher order function def main args. Yeah, so this is one of the examples which Lakshmi have mentioned. We will get back to it a little bit later. Let me first cover higher order functions. So this is regular function, and if you want to create anonymous function while applying some logic on collections, etc., Scala provides a lot of APIs which will make your job a lot more easier. For example, let's say you have an array, okay, and to create array in Scala, it is very easy. You just have to say 1 to 10 and hit enter. It will create a range of values. You don't need to create an array and then assign values in that array, okay. And we can also apply several functions on top of this range, okay. So this itself is of type range. Range is nothing but collection. So I'm talking about collection APIs now, and if I hit dot and hit tab, it will show all the functions available on that data type. Okay, this is called as autofill. You can see what all functions can be applied for any object or a class variable, whatever it is, and then we can actually explore those things to apply functions. Okay, so some of the important Scala-based functions are like fold. There is something called fold left also, and fold right. Using these things, without writing for loops, you can compute the total of values, mean of values, max of values, etc. So typically, how will you write? How you compute sum of values? You say for I. So if it is Scala, if you want to write in traditional Java way of for loop, you will see this. You will say this for I 1 to 10. Okay, I have to create a variable where total equal to 0, and then for I 1 to 10, and then total plus equal to I. Okay, and now if I say print total, it will give the total of these values. But this is not the proper way of dealing with collections when it comes to Scala. They have provided a lot of APIs which will make your job a lot more easier. So if you want to manipulate these things, if you want to just extract all the even values or odd values, and then if you have to if you want to get the total of those even or odd values, in this you have to apply if condition and check if the value is giving reminder 0 or 1. If it is divided after dividing by 2, if it is even, it has to return 0, and we have to capture those. We have to add only those things to total. So you have to write quite a bit of code to do that. If you are dealing with, if you want to implement same thing with Scala, what you can do is 1 to 10. So it will give the range of values, which is nothing but a collection. And then they provide APIs such as fold. So fold if you don't want to manipulate anything, if you directly want to add those values, either you can use fold, fold left, fold right, and also there should be some function called reduce. Okay, you can use these APIs and you can take care of adding the values and get the final total. For example, here I can say reduce, and I can say this one, and it will add all the values. Here again, this comes under optional items. When we know that when we know when we can when this function know what all values it will get, or what type of values it will get from the collection which it is trying to process. The Scala philosophy is that there is no need to define variables. So this is same as this logic. Okay, so here I am creating two parameters, total and value. I will explain the logic in a moment. And then total plus value. So you will find the functions with same names even in Spark. And here we are only talking about Scala. The same APIs, map, reduce, filter, everything, most of them are available in Scala also. The difference between Scala-based APIs such as map, reduce, filter, etc., and Spark-based APIs are Spark APIs are distributed in nature. It will apply, it will create a different type of collections, and it will apply these functions on top of those collections. They are overridden methods. Here we are talking about plain Scala functions. Okay, I will explain how reduce work in a moment, but syntax wise it will look like this. Both are same. Here we are specifying the name of the parameters. Here we are not, because the Scala philosophy is whenever the function can get the values from the input collection, there is no point in creating variables as part of the function. Okay, so now let us try to decipher this function. First, let us understand this. So we created a range which is 1 to 10, and in reduce, what we are doing, reduce will get two parameters. Okay, one is an implicit accumulator. Okay, internally it will be assigned to 0 to begin with, and value is whatever collection we are passing to this function. In each iteration, the value will change as it go through. So it's like for I 1 to 10, what will happen when we write like this? Total plus equal to I. What happens? So we have initialized the variable called total. That's what happened. That's what will happen with this. And then we are iterating through 1 to 10. So in each iteration, this value will be assigned to I, and that is being added to total. That's what is happening internally. So similar logic will be when this is compiled by Scala compiler. Similar logic will be implemented to create a global variable called total, and then the value will be assigned to it. So this logic will be compiled similar to this one by the Scala compiler. Here they are providing interfaces to minimize the amount of coding we need to do. And then, as I have mentioned to you earlier, if the function understand what it is going to get as input, there is no need to give the names to the parameters. So here this reduce function expects two parameters. So this underscore will be the global variable which is accumulator, which is initialized to 0 to begin with, and this will be value in each iteration, and these two values will be added, and so 0 and 1 will be added after the in the first iteration, and 1 will be assigned to total, and in the second iteration 2 will be added to 1 and 3 will be assigned to total. In the third iteration, total will be 3 and value will be 3, both will be added, and 6 will be assigned to total. And for that, internally it will create those implicit variables, like here, right? Even though we did not specify result 9 as variable name, internally it is creating certain variables, and it will compile into traditional for loops, while loops, etc. And then bytecode will be generated accordingly, and then the program will execute. So that's how it will work. So a lot of complexity is hidden from us. Now coming back to let's say we want to add only the even values or odd values within a given range. Okay, what we will do in traditional programming, here we will say if I mod 2 equal to 0, then add to total, otherwise discard it. That's how we write. So that is called as transformation. So if each and every element we are trying to see whether it is a even value or odd value, and then we are actually using it for aggregation. So that intermediate step is called as transformation, and one of the transformations is filter. So if I again say 1 to 10, which will give you a collection, and then hit a tab, you can see there is a transformation called filter. Okay, so over a period of time, you should know what each of these functions do. I am covering only the important ones, like reduce I have covered. You can use fold also in place of reduce in many cases. In some cases, I don't know the exact difference from between fold and reduce. The syntax will be almost same. I don't know the exact difference. I will try to get it very, very soon. In Spark world, we typically use reduce left. We typically use reduce function. We don't use fold and all in Spark based APIs. So here he's saying fold will have a 0 value. Yeah, now I remember. So when it comes to fold, if you want to implement the same logic with fold, you have to say like this. You have to initialize the total. With reduce, the total, the first parameter which is passed will automatically set to 0 to begin with. But in fold, it requires the default value. That's correct. Yeah, I got it now. That's the only difference between fold and reduce. Okay, so now let us say I want to get all the even values and add those things. Okay, so here we can use filter, and we can say if, so underscore means each element that will be passed to filter. Here we have to give a condition which will return true or false for filter. If the condition is true, like in if condition, the value will be considered. If the condition is false, the value will not be considered. So here I am saying underscore mod 2 equal to 0. Now you see we are only getting even values. If I say 1, we will get only odd values. Now I can apply fold or reduce. So if it is fold, you have to initialize the first variable, which is accumulator, and then you can say underscore plus underscore. So let's say I want to start with 100 and add values to it. I can say it here now. As we are dealing with odd values, so all these values are added to this 100, and the output is 125. Okay, so here filter is a transformation where it will either filter out the record or discard the record or consider the record based upon the condition you specified here. So this always has to return Boolean, true or false. If it is true, the value will be considered, and then pass on to the next step. Otherwise, it will discard. Okay. And now sometimes what will happen, we might have to transform an element to some other element. For example, for each and every of these values, I want to multiply with a unique value, a constant value. So here I am creating a constant c equal to 3. Okay, and for each and every even values, I want to apply some transformation by multiplying that. That is, we can do that using a function called map. These are all collection based APIs. We have seen reduce, we have seen fold, we have seen filter, we now we are seeing map. Okay, here what I want to do, I just want to multiply with c. Okay, and then I want to do the further processing. So now you can see, after filtering out all the even values, I'm able to multiply this thing using map function. If it is regular for loop, you have to include as part of the logic. Before adding it, you have to multiply and then add. So this one actually take care of separation of duties. Map will actually do the transformations by changing one element to some other element. Each element will be processed and will be done, will be converted into some other element. Filter is to filter out the unnecessary records, and reduce or fold is to aggregate by adding elements in the collection. So here there is a clear separation of duties, and there are APIs for each of those things. Yeah, sure, Ritik. The difference between reduce and fold. Okay, so now let us start with this. So if I have to add all the elements, okay, to a zero value. Okay, so our global variable which will store the total, and which needs to be printed after the processing is done. If it has to be initialized to 0, for example, if you want to implement logic similar to this, where total equal to 0, and then for 1 to 10, total plus equal to I, print I. So if this needs to be, what happened? Sorry, thank you. Yeah. Okay. So here total equal to 0. So the global variable total is initialized to 0. If you want to implement this logic with reduce, what you will do? You just have to say 1 to 10, which will give the range, and then reduce. So as for this one, we want to initialize it to 0, we can use reduce function, and then we can say underscore plus underscore, and it will give the total. But in some cases we want to initialize to a different value, like this, where total equal to 100, and then print total. Okay, now if we want to get 155, using reduce you cannot do that. You have to use the fold function. Okay, so you can say fold. It takes two brackets. The first bracket, you have to initialize the value, and the second bracket is the whatever logic we want to implement on it. So here I just want to add these values in the loop, and the global variable is set to 0. If you want to implement this logic, we can only use fold, we cannot use reduce, and we can say 100 here. So your global variable which will actually hold the total is initialized to 100, and all the elements are added to that 100, and the final result is 155. So that is the difference between fold and reduce. Fold will give a little bit more flexibility if you want to provide a seed value before adding our collection and get the total. Okay. And now if you want to adding elements is simple. If you want to get min or max value, either you can use reduce and fold here. Okay. And you can say you can say min and value, and you can say if. Here we are using ternary operator, which I have covered earlier. If min less than or equal to value, then min, else value. Okay, here we cannot use this logic. Let us see. Yeah, it is working. So let us say this is 110, 200. Sorry, 110 to 1000, let's say. So now you are getting the min value. If you want to get the max value, you can say max here. So this is a simple ternary operator, which I have explained when I talk about programming constructs. And here I have to say greater than or equal to, and we got the max value as 1000. Okay, so you can write whatever logic you want here. Here we cannot use underscore notation because in if condition it might be able to interpret, but while printing it might not know which one to print. So when it comes to min and max, we will not be able to use this one. Only in some cases where it does not change, the context does not change for the parameters, for simple addition, etc., we can avoid naming the parameters. Otherwise, we have to give the name. We have to name the parameters like this. Okay, and also we can invoke a function in this. So if you want to invoke some other function from these APIs, what we can do, we can create our own function, which is min of values. We take two parameters. Okay, and return type is integer. Okay, if I greater than, less than or equal to j, I, else j. Okay, so you don't need to specify return. Automatically it can determine what needs to be returned. Here, if it has to return I, it will return I. If it has to return j, it will return j. In Java, you have to specify return statement wherever it is required. In Scala, it can determine automatically. You don't need to type return here. And now if I have to invoke this function as part of reduce, what you can do is you can directly say reduce min of values, and it will automatically pass the parameters. You don't need to even specify, give the names to the parameters and all those things. It will automatically take the parameters because the specification is matching. Our reduce function starts with takes two parameters as input, which is the global accumulator and each element in the loop, and our min of values function is matching with the parameters passed by reduce function. Hence, we don't even need to specify the parameter names. Okay, this is how you can actually invoke the functions from existing APIs to the functions which we have created. If you want to name the parameters, what you have to do is we have to say min comma value, and then you can say this if you want, but that is not required. This will also work. Okay, so this is about functions, and this notation here is called anonymous function. Anonymous function means we are not giving any name to function. We are actually passing parameters. Sorry, not this one. This one is called an anonymous function. Okay, so we are only passing the parameters, and we are providing the logic here, and we are it will be invoked whenever we try to process the data, and that is called as anonymous function or lambda expressions. Very popular in Python or programming languages. They have included in Scala also. Okay, we can also name the anonymous function. So if you want, you can say val max equal to, and okay, mixing parameter type. Here I have to give the parameter type, and also I have to give the return type. Okay, return type is automatically inherited. If you want to give the return type, I think no, this syntax is a little bit what you have to do is you have to say int equal to I think you don't need to specify here. You don't need to specify the return type. You just have to say it here, and it will automatically take. So we can also do this val max, and we are actually giving a name to an anonymous function so that we can use it as variable somewhere else. Okay, and here we can invoke the same function. Don't worry if you understand. If you do not understand all these things, it's a little bit tough and confusing. As long as you know the basic APIs such as map, filter, reduce, etc., that is more important than understanding these nuances of the syntax. It's very clumsy because you can do the same stuff in multiple ways, and it's very tough to get the intuition unless you practice a lot. Okay, but you should know how to you should know the terms, and you should know how to manipulate the collections, etc., in Scala style compared to Java, because over a period of time it will be a lot more productive to use Scala approach than Java approach. Okay, here we can say reduce and max, and it will work. So here I have created function a variable, and the variable name is max, and type is it's a function. Okay, so we can create variables of type function in Scala. That's why it is called as functional programming language. Okay, so that's about the collection API. There are so far I have only covered range, and there are so many collection classes. There is a list, there is set, there is map. I will cover list in detail, and I will also cover set. Map, it's like hash map. We will try to see all these things tomorrow because it's almost 3:30. And from here, we will jump onto JDBC, creating the JDBC dependencies and also externalizing parameters. And then we will get into the exercise. Okay, so today what we have covered the basic programming constructs such as if, while, for. We have covered functions, and also we have covered collections, and also we have covered the difference between val and var. Tomorrow we will continue. I will try to explain how to use Scala IDE and create the dependencies for writing JDBC based code, and also to externalize the parameters such as JDBC URL, etc. And then probably day after tomorrow by the end of this week, we will try to finish this exercise of writing end-to-end application which use JDBC, connect to the database, get the data, and process the data, and we will try to create a jar file out of it, and we will try to run it on the lab. Okay, that will be the end goal of this whole exercise. This will give some basic foundation to write full-fledged Scala-based applications. And then if you want to become a application developer, you need to understand frameworks like Play, and there are many other frameworks. Just like in Java, we have J2E, Spring, etc. Even Scala is coming up with so many frameworks. If you want to become application developer using Scala, you have to explore those things once you learn core and advanced concepts of Scala programming. That being said, there is one last question which I will take, because we are already 5 minutes past of this first hour session. We will resume tomorrow. So the question from Chaitanya is, what value does min take in 1 to 10? I think min will take the first value. It will not be initialized to 0, as I have explained earlier. Min will take the first value, and then from there it will get into the go through the loop and get the results. I will get into the details. I am also not 100% sure. I thought it will not work, but it worked. But I will try to get in detail what will be the min in this logic. Okay. That being said, thank you, and we will catch up tomorrow. And one more thing is, for people who are outside from Tawant, Tawant is asking to set up this session from 10:30 to 12:30 a.m. in the morning. I'm not sure if it works for you guys. So please send an email to training@itversity.com if it works or not. By tomorrow, I need to make the decision. So let us discuss about it tomorrow, probably before the class, and then we will take it from there. Okay. That being said, you guys can take a 2 to 3 minutes break. I will close the Scala and Spark workshop session on YouTube, and I will start the second part of the session, which is big data. So Dasratha, we will take care of it in a moment. I will give you the access.
Sure, Durga.